Welcome to Mission Critical, the HARTING America's content series that offers engineers the details they need to make informed decisions and inspired solutions. Today's topic is connectors used in robotics. Let's jump in.
I think one of the key ways that robotics has advanced is typically in a manufacturing environment, robots were stationary. They were moving objects, they were handling functions, maybe painting, maybe placing things. Now robots are able to move, and this is one of the key elements. So that freedom, it's really opened the door and made things that much more dynamic. So let's talk about the basics, the difference between these types of mobile robots. There's really two types. There is the AMR, AGV, that stands for Autonomous Mobile Robot or Automated Guided Vehicle. And essentially, these are robots on wheels that are traveling through a facility or through a warehouse. Humanoid robotic is exactly kind of what's implied by the name. It's more of a human form factor. So it moves on two legs and moves in much the same way that we do, although it has motors and electrical power. The conception that the hardware doesn't matter so much as to what is inside of the robot. The expectation is essentially that whatever is inside the robot is going to work, and the challenge becomes more on the service, the software side. What is the robot actually going to do? And I would say that is a misconception because the hardware inside of the robot is as important to the robot as AI and the programming and everything else. There are three key elements when we talk about components for humanoid and mobile robotics. One, they need to be robust. Two, they need to be lightweight. And three, they need to be small and provide density. Okay, so why robust? Let's imagine that your humanoid robotic is walking through your warehouse and a sensor fails. Because the connection breaks because of the shock and vibration. Two, we've mentioned that these robots, these mobile robots, are not tethered. They run on batteries. So weight is a key factor as to how long a battery is going to last. So you don't want your components adding weight. Ideally, you want your components to perform their functions but reduce weights. And the third, density. So if the component can provide that density to allow all of the connections, all of that data, power, signal that you need for the robot to function without increasing size, then that's a winning package. The key thing that's similar with all the robots that move is that they're not tethered to a power source. So they're working off a battery. Batteries have a lifetime. Batteries need to be recharged. So the longer that the robot can be functioning and doing what it was designed to do before the robot needs to be recharged is a key. And this is a concern whether it's an AMR, autonomous mobile robot, whether it's a humanoid robot. The battery life and the ability to function before recharge is really key. So this requires power, this requires sensors, this requires processing, this requires information and data, and what brings it all together, this requires connectivity. So when we talk more specifically about connectivity, HARTING offers several solutions that are very widely adopted and utilized within the robotics market space. One of those would be our HARFlex connector, which is a high-density 1.27 millimeter pitch board connector that really checks all the boxes. It checks the density concerns, size and weight, but also robustness. So it has a unique through-hole feature for a reflow soldered board connector. Makes it much more robust than the standard solution. It's designed and tested for rail applications, for example. Another connector that's widely utilized in these types of applications is our IX industrial connector. So this is a communications product, think Ethernet communication, but it is roughly 75% the size of an RJ45. Why is it important? We talked about space size, density, all that's key. And so now we're reducing the weight, we're extending the battery life of the robot via this connector. Another product that's of interest in this space is our T1 connector, single pair Ethernet connector, which by using a single pair Ethernet connection instead of the traditional 8-wire pair, we're drastically reducing the size and the weight of the connector, but also the cabling. We haven't spoken much about cabling, but cabling is a major contributor to the weight of these devices. And so if we can reduce the size of that cable, still designed to work in an industrial space, then we're really providing an advantage there. We also do see some of our more traditional robotic connectors, typically our modular series of products that combine the power, the control signal, potentially the communication into one connector. A couple examples of that would be our HAN 3.8 connector, which is a small form factor version of kind of our larger rugged HAN industrial connector. So again, we checks the boxes for size and weight. I think we're going to look and see robots deployed in other spaces outside of just manufacturing, outside of just warehousing and logistics. For example, the agricultural industry is adopting these mobile robots for a variety of applications, you know, from killing weeds to planting seeds to doing multiple things. So I think we're just scratching the surface of where these robots are going to be used. Certainly feel free to reach out. We have our field application engineering team on standby to help you with your connector needs and questions. But also, there are a number of tools on our website. We've got configurators, for example, to build your own modular connector. But we've got information, data sheets, whatever you need is also available on the website.
For more details on the innovative solutions that HARTING Americas is bringing to robotics, contact us today.